In 8.3, we're going to look at, we talked a little bit about similarity in the last section, right? We said if you can show two shapes or figures are similar, if you can match them up through a series of rigid transformations and dilations. So we're going to look at a different way you can show that polygons are similar. So now we're not talking about any figures, we're talking specifically about polygons. So I can decide if polygons are similar, and I can find corresponding lengths, perimeters, and areas of polygons. So you guys have seen polygons a lot before, but let me just review really quick. A polygon is a shape that has at least three sides. The sides are straight, and it's enclosed. So for example, a triangle is a polygon with three sides. Or you could have a rectangle is a polygon with four sides. Or a pentagon has five sides. So it's an enclosed shape with straight sides. So that's what we're focused on today, is specifically polygons, and we're going to talk about another way, how you can tell they're similar besides using similarity transformations. So if you look at this, if I asked you, are those polygons similar, justify your answer. If we're using our definition from yesterday, I'd have to take this shape and show how I could match it up with that corner and rotate it and do a dilation, and I would show that they matched up perfectly. Now, specifically for polygons, there's another way to tell if they're similar. So I want you to copy this down in your notes. It says similar polygons are two polygons with the same shape but not the same size. Right? We already knew that. To prove that two polygons are similar, we have to show two things, and it has to be both. Okay, so if you want to put that down, it has to be both. So number one, you have to show that they have corresponding angles that are congruent. And number two, you have to show that their corresponding sides are proportional. So if you want to pause the video and write those two things down, and then I'll show you some examples of how you can tell if polygons are similar. So here is an example. Let's look at this first, like this example A right here. So I've got these two quadrilaterals, right? They have four sides. Okay, the two things I have to check. Number one is if the corresponding angles are congruent. Well, these four are all 90 degrees and these four are all 90 degrees, so we can check that one off. The corresponding angles are congruent. Number two is we have to show that the sides are proportional. So when I do that, just be careful. This side is going to be 10, this side is going to be 15, this side is going to be 15, and this side is 20. So what I want to do to show that they're proportional is to compare their ratios. So I'm going to take the two short sides. I got the 10 and the 15 are the short sides, and set up a ratio. And the question is, does that equal the ratio of the two longer sides, 15 and 20? If those two ratios come out to be equal, then we say the sides are proportional, and we can check off the second thing, and they would be similar. So let's just check that. 10 15ths, I divide them by 5, I get 2/3. 15 20ths, I divide them by 5, I get 3/4. Well, they're not equal. So that second thing, right, was the sides have to be proportional. We would say no on that one. So the question is, are they similar? The answer on this one is that they're not. Let's check these next shapes. So I've got these pentagons. So look at the angles first. Just a reminder that, right, a single circle like that means that those two angles are equal. Those have the same symbol, so they're also equal. So A is equal to S and D is equal to U. E has a 2 line, so it's equal to T that has 2 lines. And then R and V are both right angles, and so are B and C. So number one, right? Are the angles congruent? Yes. Number two, are the sides proportional? So let's set up our ratios and find out. So I'm going to go just the little one to the big one. So I'm going to start with this side. That goes with this one. So that ratio, right, is 9 to 18. This one is also 9 to 18. I'm not going to rewrite it. That one's also 9 to 18, so I don't need to rewrite that one. This side is 6, and this side is 12. So 6 to 12. And then this side is 6, and this side is 12, so it's the same ratio. So the question is, are these two equal to each other? So I reduce those. This comes out to be 1 over 2. That comes out to be 1 over 2. So they are equal. So we check off the second box. So the question is, are they similar? We would say yes. And the reason why is the corresponding angles are congruent, right? That was number one. And the sides are proportional. That was number two. Now, the second part says write a similarity statement. We haven't talked about what a similarity statement is, so let me show you. A similarity statement is just, you're basically saying that this pentagon A, B, C, D, E is similar to this other one. So there's a shorthand way of doing that. We say A, so I'm just going to write it down as A, B, C, D, E is similar to, that's the symbol for similar. And the other one, what you have to be careful with is the corresponding angles have to go together. And what I mean by that is that this angle A goes with angle S. So if A comes first, S has to come first. Then we went to B, which is the right angle. So we'd go to R, which is the right angle. Then we went to the other right angle. So that would be V would go with C. And then we go to, next you go to D over here. That would be with U. And then we go to T, which is with E. So just being careful that these, A and S, and B and R, and C and V, and D and U, and E and, oh, that shouldn't have been E and E, I'm sorry, it's E and T. My bad. And T, E and T all correspond with each other. All right, I want you guys to try this number 3 really quick, so pause the video. So you're determining whether they're similar or not, and then write a similarity statement if they are. Okay, let's just check this. So first of all, we can see that L and R are similar. I'll like color code them. And K and Q are similar. And then these J and P are both right angles to there. So number 1 checks off. Like the angles, the corresponding angles are congruent. Okay, number 2 is, are the sides proportional? So if I look at this, I'm going to pick one of the sides. So I'm going to start with this side right here. It's the shortest side. It's got to go with the shortest side over there. So that ratio would be 8/16. And then let's compare the longer leg, 15, to the longer leg, 30. And then let's compare the hypotenuse. These are right triangles, so hypotenuse to the hypotenuse. So the question is, whoops, that was a 17/34, yeah. So the question is, are those proportional? Well, if I reduce all those, they come out to be 1/2. So they are equal. So we just showed the corresponding angles are congruent and the sides are proportional. Okay, let's write our similarity statement then. So just pick one of the triangles. It doesn't matter which one. So I'm going to pick the first one and call it KJL. Triangle KJL is similar to, and you don't have to go in the order KJL. What does matter is that K has to go with Q. So if K came first, then I'm going to have to put Q first. Then I went to J, which is the right angle. So that would be P. Then I went to L, which is the last one there. Oops, sorry. So I went to L on the first triangle. So this one would be R goes with L. So when you write the similarity statement, I'm going to slide a triangle in there. When you write the similarity statement, the angles, the corresponding angles have to go in the same order. And the second part of the assignment will be if you're given similar triangles, that you need to find congruent angles, and you need to show that the ratios of the sides are equal. So this one says, I got this triangle RTS and XZY. And it says to find the scale factor from RST to XYZ. So just be careful. This is important. I'm going from the big triangle to the little triangle. All right, it says from RST to XYZ. So find the scale factor. It says list the pairs of congruent angles and write the ratios of corresponding side lanes in a statement of proportionality. And I'll show you what that is. So let's start with A. So let's find the scale factor. Hey, by the way, up here it tells us that they're similar. So we're not trying to show that they're similar. We already know that. We're just going to use the fact that they're similar to answer this question. Okay, so if I look for my scale factor, pick the sides that go together. The shortest legs, the 20, would have to go with the shortest leg there, which is the 12. So I'm going to set that up, and it's either going to be 20/12 or 12/20. We have to decide which one. Where I'm going from the big triangle to the small one. Remember we talked about this. That means the scale factor has to be less than 1. So this is going to be my answer right there. So 12/20 reduces to be, what, 3/5? Or you put 0.6 or 60%. Okay, part B says list the pair of congruent angles. Well, right, I know T T is between the two longer legs, so it has to match up with Z. So all I put down is the angle T is congruent, that's the sign for congruent, to angle Z. Pick another pair, so I could do like R and X. So angle R is congruent to angle X, and S and Y. Angle S is congruent to angle Y. Okay, so those are the list of pairs of congruent angles. And then the statement of proportionality just says this, is if I set up the proportions between the angles, so I got 25 to 15, this is C over here, 25 to 15 is equal to 20 to 12, which is equal to 30 to 18. That's what it means when it says to show that statement of proportionality. We could reduce all those. You would see they came out to be the same thing. I think they all come out to be 5/3 on all three of those. Okay, so if the triangles are similar, we have all these congruent angles, and we have the sides are going to be proportional to each other. Okay, we can use this to find missing sides. So if you look at this one again, it tells us triangle DEF is similar to MNP, and it wants us to find out what X is equal to. All we're going to do here is just set up our proportions. So I want to find X, so figure out what side X goes with, and that would go with 30. So I know X goes with 30. And all I needed to come up with is another ratio, and I actually have two of them. I could do 15 to 18 or 20 to 24. What I have to make sure, if I put X up on top, right, that means that the 15 has to be on top or the 20 has to be on top. So I'm just going to pick 15 over 18. So I can just set up that proportion. Because I know that they're similar, I know their sides are proportional. And now it's just a matter of solving this. You guys have solved stuff like this before. It may have been a while, but the easiest way to do it is just to cross multiply. So I'm going to go X times 18, 18X equals 30 times 15, which is, what, 450, I believe. I don't have a calculator here with me. But divide by 18. And I think it comes out to be 25. I don't know. You can plug that in a calculator and see if that's right, but I'm pretty sure it comes out to be 25. Okay, so if you know the triangles are similar, you can use that to find a missing piece. Here's one that's a little more complicated. Those are pretty simple. This is the one I want to do right here. It's just number 31. All right, so this one tells me that WJL is similar to QBV. Now these are kind of confusing because they're rotated, but if you look up at the similarity statement, if W comes first and Q comes first, they have to be the corresponding angles. So those two right there have to go together. And then L comes next, so it has to be L and B. And then J and V come last, so you can kind of tell which ones go together. All right, so let's set up a similarity statement. So this side has to go with that side. So I'm going to set up that ratio. X plus 6 over 8 is equal to, and this side has to go, it's between W and L, so it has to be between Q and B, which if this side is 5 over here, they have to be 5 too, right, because they're congruent. So I'm going to go X over 5. Okay, this is my proportion I have set up. Now I'm just going to solve it, so just cross multiply. So 8 times X and 5 times X plus 6. When you do this, make sure that 5 carries through to both. So you end up with 8X equals 5X plus 30. Now just use our good algebra skills to solve it the rest of the way. So I'm going to minus 5X. So 3X equals 30. Divide by 3, end up with 10. So X equals 10. So just be careful. You guys have solved proportions like that before, but it's probably been a while. So hopefully that's a reminder for you. Hey, the last two things you need. The first thing is this. If you want to write this down, it says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So if you want to pause the video, write that down, and then I'll show you an example. All right, so if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their side lengths. So if I can find the ratio of their sides, I can find the ratio of their perimeters also. So let me show you how we could use that. This says a town plans to build a new swimming pool and an Olympic pool is rectangular with a length of 50 meters, no width of 25 meters. The new pool will be a similar shape. I'm going to draw it down here, but the length will be 40, and it wants us to find the perimeter of the Olympic pool and the new pool. Well, the Olympic pool is easy, right? It's a rectangle, so that side has to be 50. I add all that up. I think it's 150 meters. That's the perimeter of the Olympic pool. Well, I could use proportions to find this side, but there's another way we could do this. If I know the ratio of the two pools, what I mean by that is I can compare them. Like I'm going to go, and I'm going from the big pool to the little pool. So I'm going to go put the 40 and the 50 together. I'm going to put the 40 on top because I'm going from, I want it to be less than 1. And if I reduce that, my scale factor comes out to be 4/5. So what I can do is I can take what this says up here is if I know the ratio of the sides, I know the ratio of their perimeter. So the ratio of their sides is 4:5. That has to be the ratio of their perimeter too. So if the perimeter of the Olympic pool is 150 meters, if I just times that by 4/5, that will tell me the perimeter of this smaller pool right here. Okay, so let's do that. Let's see, 5 goes in 150 30 times. 30 times 4 is 120. So it's supposed to be 120. So 120 meters. Now, we could have also just gone like this, right? I could have just taken 25 and times it by my scale factor. I think it comes out to be 20. And then I would have known all the sides, and we could have added it all up there. But if we use that theorem, all that theorem says is if I know the scale factor of their sides, I know the scale factor of their perimeters. The other one, the last term you need to know is this, is comparing the areas. So if you want to write this down, it says if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So what we have to, this is a little bit different. Let's actually do this. Pause the video and write that down, and then I'll show you an example of what this looks like, because this one's a little bit different from the last one. Okay, so the two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding sides. All right, so if I come down here, what that means, so it tells me, I got these two triangles, it tells me that they're similar. So if I know the ratio of their sides, I can find the ratio of their areas. So it tells me, right, A and B, AB goes with DE, right? It's in the same order. So that ratio, and I'm going to go from the big triangle to the little triangle. So I want my scale factor to be less than 1. So it's going to be 5/10, which is a half. Now this is a tricky part. With perimeter has the same ratio, the same scale factor as the sides do, the lengths of the sides. Area, what that theorem says up above, is to find the scale factor of the area. So I'm going to put down here the area. I take the scale factor of the sides and I square it. So I go a half squared. Well, a half squared is a fourth, right? I square the 1 and I square the 2. So now I come up here. If I know this area is 36 square centimeters, if I just go 36 times a fourth, that will give me the area of the smaller triangle. So 36 times a fourth, that'd be 36 divided by 4 is 9. So we say that smaller triangle has an area of 9 square centimeters. So you find the ratio of the sides and then you square it. That's what I did right there, right? And that gives you the ratio of the areas of the two shapes. It's kind of interesting why it works that way. And I'm not going to get, just to keep these videos somewhat short and not make them too long, I'm not going to get too into it. But, talk to me about it when you get back to class and I can kind of show you that because it is kind of interesting why it works that way. Okay, I want you guys to try this problem. So it tells me the area of this smaller rectangle is 84 square centimeters. It gives me this side and this side. It wants me to find the area of the big rectangle. And it gives us this, it tells us that they're similar. So pause the video, give this one a try, and then come back and I'll run through it with you. All right, so we know that KJ, or JK, right, JK goes with NP, that side right there. So I can find the scale factor of those sides. I'm going to go, and we're going from the little triangle to the big triangle. So I want it to be greater than 1. So I'm going to go 21 over 7, which comes out to be 3. So our scale factor is 3. Now this is a tricky part. For the area, that was bad. All right, area, I've got to take the scale factor and square it. So the scale factor for the area would be 3 squared. So it comes out to be 9. So I know the area of the small one is 84, so I take the area of the small one, I times it by my scale factor, which is 9, and multiply those together. So this is going to be dangerous. I'm going to try doing this in my head, but see, 80 times 9 is 720, right? And then 4 times 9 is 36, and you add those together, is that 756? You can check that. But I think that's what it comes out to. So it comes out to be 756 square meters. So really, really important is if with perimeter, the sides and the perimeter have the same scale factor. With area, you have to take the scale factor of the sides, the lengths of the sides, and you have to square it, okay, in order to find the scale factor for the area. Okay, that should be everything you need to know. Let me know if you have questions. Best of luck.